Welcome to the prerequisites in physical science. Today we are going to learn about the acid, bases and salt for class 10. So before going to learn this lesson acid, bases and salts, we should have some prerequisites which we have already learned in our class 7th. So today we are going to recall and rewind all the prerequisites one by one which we have already learned in our class 7th. Let us see what are the prerequisites we must have before learning this lesson, acid, bases and salts. So for all the prerequisites are nature of acids and bases, different types of acids, indicators, different types of indicators, chemical reactions of acids, acid rains, how bases are formed, salts, uses of acids, bases and salts in our daily life. So let us recall all the prerequisites one by one. First, nature of acids and bases. So generally acids are sour in taste. రుచికి చాలా పుల్లగా ఉంటాయి. మనం గనక ఎప్పుడైనా have you observed when you are eating lemon, orange, grapes, they are very sour in taste. Generally bases are bitter in taste. So bases అన్ని కూడా చేదుగా ఉంటాయి and bases are soapy to touch. పట్టుకుంటే జారిపోయే స్వభావాన్ని కలిగి ఉంటాయి. For example, when you touch the soap and detergent, you feel like soapy to touch. So those are all bases. So the nature of acids and bases, acids are generally sour in taste and bases are bitter in taste. Next, types of acids. So acids are two types. So first one is natural acids and second one is mineral acids. So let us see what are natural acids and what are mineral acids. Natural acids. Natural acids which are present in plants and animals are called as natural acids. For example, lemon, orange, grapes, tomato, apples, tea, oils, fats and urine, etc. These are generally found in plants and animals. That's why these are naturally present in the plants and animals. That's why these acids are called natural acids. Mineral acids. The acids which are prepared from minerals are called mineral acids. They are synthesized in the laboratory and they are prepared from some minerals. So these are called mineral acids. Example, hydrochloric acid, sulfuric acid and nitric acid. Indicators, వీటిని మనం తెలుగులో సూచికలు అని కూడా అంటాం. So indicators are the substances which indicates a change in color when some substances are added to them. సో ఈ ఇండికేటర్స్ని మనం యాసిడ్స్ కానీ బేసెస్ కానీ తీసుకొచ్చి వాటిలో పెట్టినప్పుడు దే షో సమ్ స్పెసిఫిక్ కలర్ చేంజెస్ విచ్ ఇండికేట్స్ దట్ ద సబ్స్టెన్స్ ఈజ్ వెదర్ యాసిడ్ ఆర్ బేస్. దట్స్ వై దీస్ ఆర్ కాల్డ్ ఇండికేటర్స్. వీటిని తెలుగులో మనం సూచికలు అని కూడా పిలుస్తాం. రకరకాల కలర్స్ని చూపించడం ద్వారా అవి యాసిడ్సా బేసా అన్న విషయాన్ని మనకి తెలియజేస్తాయి. దానికోసమే వీటిని మనం ఇండికేటర్స్ లేదా సూచికలు అని కూడా పిలుస్తూ ఉంటాం. Types of indicators. There are two types of indicators are there, natural indicators and chemical indicators. What are natural indicators and what are chemical indicators? Let us see. Natural indicators. These are extracted from some flowers and vegetables. Flowers like hibiscus, oleander, lichens, etc. అంటే మనం మందారాలు, హైబిస్కస్ అంటే మందారాలు, ఒలియండర్ అంటే గన్నేరు పూలు, అలాగే కొన్ని లిచెన్ జాతికి చెందిన కొన్ని ఫ్లవర్స్ యొక్క పిగ్మెంటేషన్ నుంచి దే ఆర్ ఎక్స్ట్రాక్టెడ్. అండ్ వెజిటబుల్స్ లైక్ బీట్రూట్, రెడ్ క్యాబేజ్ అండ్ టర్మరిక్ ఎట్సెట్రా. For natural indicators are blue litmus and red litmus. These blue and red litmus are extracted from the color pigmentation of the flowers like lichens. They are extracted from the color pigmentation of lichens. That's why these are called natural indicators. Chemical indicators. These are prepared in laboratory by using some chemicals. So example for chemical indicators are methyl orange and phenolphthalein. These also shows some different color changes when they come contact with acids and bases. Let us have an activity. What type of changes they can show when they are kept in acidic or basic substances? Let us see. So here we can take the lemon, tamarind juice, soap water and a glass cleaner. And here red litmus, blue litmus, methyl orange and phenolphthalein. These are the indicators. First take the red litmus and dip in the lemon juice. Observe the color change. There is no color change. Red litmus remains red. Then take blue litmus, dip in the lemon juice. Observe the color change carefully and closely. So, see, the blue litmus turns to red color. That means lemon is acid. So, blue litmus changes to red color in acids. Again, take the red litmus and dip in the turmeric juice. There is no change in red litmus. It remains same color. Again, dip the blue litmus in the tamarind juice. See, the color changes to red color. So, lemon and tamarinds are both are acids. So, blue litmus changes red color and red litmus remains the same. Now, take the red litmus and dip in the soap solution and observe the color change. So, it turns into blue color. Again, dip the red litmus in the glass cleaner solution. This also changes to blue color. And take the blue litmus and dip in the soap solution. Blue litmus remains the same. There is no color change in blue litmus. And in the case of glass cleaner also, blue litmus remains the same color. So, soap and glass cleaners are bases. That's why red litmus changes. Now, take the methyl orange solution. Add 1 or 2 drops of methyl orange solution in lemon juice. Observe the colors. It is red color. And add 1 or 2 drops of methyl orange solution to the tamarind juice also. It is also changes to red color. Lemon and tamarind both are acids. So, methyl orange change red in color. And in soap solution, it changes into yellow color. And in glass cleaner also, observe the color. It is also changes to yellow color. So, soap and glass are bases. It is yellow. Now, take the phenolphthalein indicator. Add the phenolphthalein indicator to the glass cleaner. It changes to pink color. And when it is added to soap solution, it is changes to pink color. Soap and glass cleaner are bases. The color change is pink. In tamarind, there is no change. And lemon also, there is no change. So, let us have the color change table. So, the color changes by the indicators. So, there are blue litmus, red litmus, methyl orange and phenolphthalein. Let us find out the color changes. When blue litmus is added to acidic medium, its color changes to red color. When blue litmus is added to base, there is no change. It remains as blue color. Whereas in the case of red litmus, when it is dipped in the acidic medium, there is no change. It remains red. And whereas in case of base, it changes to blue color. In case of methyl orange, when it is come contact with acidic medium, its color changes to red color. Whereas in case of base, it changes to yellow color. So, phenolphthalein, in the case of phenolphthalein, when it is dip or come contact with the acidic substances, there is no change in that color. It doesn't show any color change. And in case of base, it shows the pink color. These are all the color changes which are shown by the different types of indicators: blue litmus, red litmus, methyl orange, phenolphthalein. So, these are all indicates whether the substance is acid or base by indicating some specific colors. Let us see the next prerequisite: chemical reactions of acids. So, in this part, we discuss about the reaction of acids with metals. Generally, when acids react with metals like zinc, aluminum, magnesium, calcium, they produces salt and a colorless gas which is called hydrogen gas. What is the test for hydrogen? When we bring a burning candle or bring a burning matchstick, it produces pop sound, which indicates the liberation of hydrogen. Generally, in the reaction of acids, hydrogen gas is liberated in general. Let us see the pop sound and the hydrogen gas liberation in this activity. Take some zinc granules. Zinc is a metal here. So, 2 or 3 are pieces of zinc granule. Add lemon juice. It is a natural acid. Add lemon juice to the zinc granules, a metal here. An acid is reacting with metal. Observe the reaction carefully. So, a reaction is going to take place in that test tube, and a colorless gas with bubbles is coming out from the test tube. Just hear the sound. Yes, it's a pop sound. It indicates the liberation of hydrogen gas. Next comes to chemical reaction of acids. The second reaction is reaction of acids with metal carbonates. Generally, acids react with metal carbonates like calcium carbonate, sodium carbonate, and magnesium carbonate. These acids react with metal carbonates and produces a fizzy type gas and quick effervescence like called carbon dioxide. The test for carbon dioxide is when this gas is passed through the lime water, this gas changes the lime water into milky white. This is the test for the carbon dioxide. So in the reaction of acids with metal carbonates, generally salt and carbon dioxide will be liberated. Let us see the activity in this. So take the eggshell powder. Eggshell powder is nothing but calcium carbonate. So take a few eggshell powder, say 5 grams of eggshell powder in a test tube. Add HCl. It's a mineral acid. Add HCl. So here an acid is reacting with the metal carbonate, that is calcium carbonate. So close that with a rubber cork and pass the gas to the delivery tube and observe the reaction which is taking place in the lime water. So observe carefully. Some bubbles we are observing. So the bubbles are nothing but the carbon dioxide. These carbon dioxide will turn the lime water into milky white. So here the color change. So it indicates the liberation of carbon dioxide. Next, our chemical reaction of acids, that is neutralization reaction. So what is neutralization reaction? In this reaction, when acid or bases are combined or there is a reaction between acid and bases, salt and water will produce. So generally it is a very crucial reaction which is very useful for us. In this 10th class, you are going to learn more about what are the uses of neutralization reaction. So in neutralization reaction, an acid and a base will combine and form salt and water. This is called neutralization. In this reaction, excess of acid or excess of base will be neutralized with the opposite. That means if there is excess of acid, we have to add base. If there is excess of base, we have to add acid to them. And finally, we have to neutralize the reaction. Finally, we find the salt and water. Let us see the reaction. So take the soap solution in a test tube. Add the phenolphthalein indicator. So as we know that soap is a base, and when we add the phenolphthalein indicator to that soap solution, we'll get the color change. What is the color change? Yes, it is a pink color. So the soap water turns into pink color. Then we are adding, soap is a base, now we are adding the HCl. A acid is going to be added to that soap solution. Let us observe what is happening in the test tube. So slowly neutralization reaction is taking place in the test tube. So slowly you can observe that the pink color is also slowly disappearing. So by adding some more drops of HCl to that solution, we finally get the colorless solution. So suddenly all the pink color is going to be disappear. That means the solution is neutralized. The soap base is neutralized by a acid, that is nothing but HCl. This reaction is known as neutralization reaction. You are going to learn more about in this 10th class. Next, our prerequisite is acid rains. Have you heard about acid rains? Acid rains are very dangerous and very harmful to our environment. So how this acid rains happens? So daily from the vehicles and the chemical factories, so much of pollution is releasing daily. So generally this pollution contains so many gases like carbon dioxide, nitrogen dioxide and sulfur dioxide. When the rain comes, generally these oxides, carbon dioxide, nitrogen dioxide and sulfur dioxide. When rain comes, they dissolve with the water and form corresponding acids. For example, when carbon dioxide is dissolved in water, it produces carbonic acid. When nitrogen dioxide is dissolves in water, it produces nitrous or nitric acid. When sulfur dioxide, when it dissolves with water, it produces sulfurous or sulfuric acid. All these acids form when they fall as acid rain on the ground. These acid rains are very much harmful for our environment, to the plants and to the aquatic creatures which are present in the water. They are very sensitive towards the acid rains, and these acid rains also may cause the damage to the historical beautiful monuments like Taj Mahal. So they make the Taj Mahal dull. because Taj Mahal is built with marble. Marble is nothing but calcium carbonate. As we already learned in the previous, that calcium carbonate react with acids, they produce some reaction. So the beauty of Taj Mahal will be diminished and it is going to be dull. So acid rains are very dangerous for the historical beautiful monuments like Taj Mahal and Charminar. Now we already know that how acids are formed. So when non-metal oxides are dissolved with water, acids will form. Then how bases are formed? When metal oxides dissolve in water, they produces base. Metal oxide means magnesium oxide, calcium oxide, sodium oxide, potassium oxide, like this. When they dissolve in water, they produce bases. So metal oxide when react with water, they produce base. Let us see how bases are formed. See this activity. We are taking a magnesium ribbon with the help of the tongs and burn the magnesium ribbon in the presence of oxygen. So after some time, it burns with a bright dazzling light. Observe carefully, it is going to be burned with a bright dazzling light. Kallu mirumitlu golputu vache kanti antaru chusara ala, with dense white fumes and with white powder color ash like. So collect all the powder in the bowl. So this is nothing but magnesium oxide. When magnesium reacts with oxygen, it produces magnesium oxide, a colorless white color powder. So collect all the powder in that given bowl, and after some time we have to let them make it cool, and after some time we have to add water to this magnesium oxide. We are adding water to the magnesium oxide. That means here magnesium oxide is dissolved in water. So what is the nature of the solution? So let us try with the red litmus. When red litmus is dipped in this solution, it turns, observe the color change, whether it turns to blue or whether it remains the same. Let us see. So when red litmus is dipped in the magnesium oxide solution, it turns into blue color, which indicates that magnesium oxide when dissolved in water, it shows the basic in nature. So bases are formed when metal oxides dissolve in water, bases are generally formed. And when non-metal oxides dissolve in water, acids are formed. That's why the formation of acids and bases takes place. Now let us see the salts. When acid and bases are mixed in a chemical reaction takes place and a salt is formed, it is already known that the reaction is known as neutralization reaction. The nature of the salts depend upon the acid-base ratio and their concentration. For example, when you mix the higher concentrated acid through a lower concentrated base, the resultant salt will be acidic in nature. When you add higher concentration of base to the lower concentration of acid, the resultant salt will be basic in nature. When both the acids and bases are mixed with the same ratio and proportion and their concentrations are the same, then the resultant salt will be the neutral in nature. So that's why salts are formed. These salts are very much useful in our daily life. So salts means, let us remember the table salt, which is nothing but sodium chloride, daily we use in cooking, and bleaching powder and washing soda and baking soda. These are all the salts which are example for the salts. Let us see uses of acids and bases and salts in our daily life. So what are the uses of acids? So generally acids are used in the preparation of pickles and cool drinks and manures, batteries. So generally what type of pickles we are going to preserve every year? So the pickles are very sour in taste, like raw mango, lemon and tomato. So all the pickles are nothing but acids. And cool drinks, in that cool drinks we dissolve the carbon dioxide. When we open the cool drink cap, a fizzy gas will be come out, that is nothing but the carbon dioxide. When the carbon dioxide is dissolved in water, it becomes the cool drink. And manure, so many manures we are daily using to fertile our land are nothing but they are prepared from acids. And battery acids also, we are using batteries. In that battery some acid is present, and the acid is also used in batteries. And dyes, it is also acids are used as dyes, and acids are used as medicines also, and acids are used as explosives. పేలుడు పదార్థాలు కూడా యూజ్ చేస్తుంటారు. And coming to the bases, they are very useful, and bases are used in the preparation of soaps, detergents. So daily we are using bathing soaps, cleaning soaps and washing soaps. So soaps and detergents are prepared from the bases, and glass cleaners also, they are prepared from the bases. And bleaching powder and bases are also used in fire extinguishers. So fire extinguishers ante మంటలు నార్పే యంత్రాల్లో కూడా కొన్ని రకాలైన కాల్షియం హైడ్రాక్సైడ్ లాంటి బేసెస్ ని అక్కడ మనం వాడుతూ ఉంటాం. నెక్స్ట్ కమ్ టు సాల్ట్స్. ద యూజెస్ ఆఫ్ సాల్ట్స్. సాల్ట్స్ ఆర్ యూజ్డ్ ఇన్ కుకింగ్, ఎస్పెషల్లీ మనం రోజు తినే ఉప్పు, అది కూడా ఒక సాల్టే, నథింగ్ బట్ సోడియం క్లోరైడ్, దట్ ఈస్ ఆల్సో కాల్డ్ టేబుల్ సాల్ట్. అండ్ సాల్ట్స్ ఆర్ యూజ్డ్ యాజ్ washing soda. It is also a washing powder, and washing soda, it is a salt. And salts are used in the preparation of cakes and breads. So in preparation of cakes and breads, we use baking soda. It is another salt, and it is also makes the cakes and breads soft and spongy. And uses of acids, bases and salts in our daily life. You are going to learn more uses of salts in our 10th class. Let us have evaluation. Why are pickles, jams and jellies are kept in glass, plastic or porcelain containers? ఎందుకు పికిల్స్ని కానీ జామ్స్ని కానీ మనం గ్లాస్ పాత్రలో కానీ ప్లాస్టిక్లో కానీ పింగాణీల్లోని ఎందుకు జాగ్రత్తగా భద్రపరుస్తాం? What is the reason for the damage to the building and monuments like Taj Mahal? What could be the reason for the damaging of buildings like Taj Mahal? And what is the color change of lemon juice with blue litmus paper? Find out the answers for these 3 questions. Today we have recalled all the prerequisites which we have already learned in our class 7th. These are very useful to learn the lesson acid, bases and salts in class 10th. So that's all for this prerequisite class. Thank you.